Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. Our topic for today is about the pH scale. So what is the pH scale? pH is basically abbreviated as the potential for hydrogen, and it is calculated by taking the negative logarithm value for the hydrogen ion concentration in the solution. We have read about pH in our previous lecture as well. And we have read that if pH is equal to 7, then the solution is neutral. If pH is greater than 7, then the solution is considered as basic solution. And if pH is less than 7, then the solution is considered as the acidic solution. So how can we determine the pH of the solution? Chemists generally describe pH in three ways. First one is the litmus paper. Second one is with the help of the pH paper. And third one with the help of acid-base indicator. So first we will discuss about the litmus paper. Litmus paper are basically the water soluble dyes that are adsorbed on the filter paper. And these dyes are extracted from lichens. Lichens are the organisms just like those of plants that usually grow on the bark of the trees. So from those lichens the dyes are extracted, and those dyes are then adsorbed on the filter paper. And these dyes when adsorbed on the filter paper work as a litmus paper in order to identify whether the solution is acidic or basic. So we have read before that acids turn the blue litmus paper red and the base turns the red litmus paper blue. So we will understand this turning of litmus paper into red and blue with the help of a video. So in this video we will conduct an acid and base test. There are two kinds of litmus paper here, red, as you can see here, this person is putting 3 stabs of red litmus paper individually. Now this is the blue litmus paper. Now we have 3 solutions. First one is the lime solution. This person put the drop of lime solution on the red as well as the blue litmus paper. Now the lime solution turned the blue litmus paper red. This means that the lime solution is acidic in nature. Now this person is putting the soap solution on the red and blue litmus paper. Now since the soap solution is basic in nature, so it will turn the red litmus paper into blue and the blue litmus paper will remain the same. Now this person is taking vinegar. We know that acetic acid is present in the vinegar. Now when the drop of vinegar was put on the red litmus paper, it didn't change color. However, when it was put on the blue litmus paper, it turned red. So this is how you can conduct an acid-base test with the help of a litmus paper. Now with the help of litmus paper, you can only identify a certain solution if that solution is acidic or basic in nature. But with the help of litmus paper, we cannot measure the exact value for the pH of that solution. So, in order to measure the pH of that solution, we adopt certain other procedures. Another method to describe the pH of a solution is with the help of the pH scale. Just like this scale, as you may see here, that this scale starts from 0 to 14. The values from 0 to 6 represents the value for the acidic solutions. All the solutions that gives the value for pH between 0 to 6 will be considered as acidic solution, and the solutions with the value of pH equals to 6 will be considered as a neutral solution, and the solution with the value from 8 to 14 will be called as the basic solution. So what happens basically when a pH paper is dipped in a solution and we don't know the pH of that solution, then after dipping the pH paper in that solution, we observe a color change on that pH paper. Now that after changing of color of the pH paper, we take that pH paper out of that solution and compare the color of that pH paper with the pH scale mentioned here. Now the color that corresponds to the color present in the pH scale will determine that what is the pH of that solution. If that color is red, then we will get to know that the solution of pH of that solution is between 0 to 1. If that color of that pH paper is you may say green, then we may know that the pH of that paper is between that solution is between 5 and 6. So this is how that pH paper may be employed to exactly determine the pH value of that solution. So pH scale is basically a numerical scale that tells you whether a solution is acidic or basic in nature. You may notice that the pH scale is from 0 to 14 value. Now this 8 to 14 will be considered as the basic range, and 0 to 6 will be considered as the acidic range. And the pH 7, as you know, that it is considered a neutral pH. Now smaller the pH, higher will be the acidity. Always remember that smaller the pH, higher will be the acidity. Greater the pH, greater will be the basicity. You have to memorize this. Smaller the pH, higher will be the acidity. For example, if we have two solutions, solution A and solution B, both are acidic in nature. Solution A has pH 2 and solution B has pH 4, for example. Now, the solution A would be more acidic because its pH is lower than the solution B. So always remember, smaller the pH, higher the acidity. Higher the pH, higher the basicity. If you have two solutions, solution A and B, both are basic solution, and the solution A has a pH 14 and the solution B has pH 13, then the solution A would be more basic than the solution B. Now we will see a short video on the pH scale. In this video, we are going to have a look at the pH scale and some other indicators of acids and alkalis. In other videos, we can tell if something is acidic, alkaline or a neutral by using an indicator. Indicators are substances that show different colors when they are in acidic or alkaline condition. Litmus paper is a simple indicator that tells us whether something is acid or alkali. Litmus is red in acid and blue in alkalis. Litmus paper is made from lichens which have been used to dye cloth for hundreds of years. It can be used as a liquid or a paper. The paper is easier and more reliable. It comes as red paper and a blue litmus paper. Red litmus paper changes color under alkaline condition but no change under the acidic condition. Blue litmus paper changes color from blue to red under acidic condition but no change under the alkaline conditions. So just remember that red litmus paper changes color for alkalis and blue litmus paper changes color for acids. However, litmus paper only tells us whether something is acid or alkali, but it doesn't tell us how acidic or how alkaline a substance is. For this, we have the pH scale and a universal indicator. Universal indicator is a mixture of different indicators or dyes which has many different color changes and so shows us the pH value of the solution. Again, it can be used as a liquid or a paper. The pH scale runs from 0 to 14, with 0 being extremely acidic, 7 being neutral, and 14 being extremely alkaline. Stomach acid is a strong with a pH of about 2. Acid rain has a pH of about 5.5. Milk is neutral with a pH of 7. Seawater is slightly alkaline in nature. Soapy water is strongly alkaline and bleach is really strong alkaline with a pH of 13. Universal indicator is so called due to its ability to indicate the entire pH spectrum. There are other indicators that can be used that we have other color changes, but these two the one we need to know. We can also get even more accurate measurement of the pH using a pH meter, which will give us reading to 0.01 of the pH. So from this lesson, you should know what indicators can tell us whether something is acidic or alkaline and how acidic or alkaline it is. Red litmus paper changes color for alkalis and blue litmus paper changes color for acids. And universal indicators can give us more detail indicating where on the 0 to 14 pH scale a solution is. Acids are from 0 to 6, neutral is 7, and alkali from 7 to 14. Another way to determine the pH of the solution is with the help of acid-base indicators. Acid-base indicators are the substances that respond to change in the hydrogen ion concentration. What are indicators? Indicators are basically the intensely colored organic compounds, and they indicate the pH of solution by the color change. The change of color of solution for these indicators takes place within small pH range. And how do these indicators show the pH of that solution? We take a few drops of indicator and we put it in the aqueous solution of an unknown pH. Now, when that indicator is put into the aqueous solution of an unknown pH, then we get the color change of that solution. And with the help of a color change, with the help of a resulting color, we measure the pH of that solution. Here are some pH indicators that we usually employ, and they have different colors in the acidic as well as the basic medium. For example, for the phenolphthalein, we have the colorless solution if that solution is acidic, and when that indicator is put in the basic solution, then that solution turns red. Similarly, for a methyl orange, when that indicator is used for a solution, acidic solution, then in acidic solutions it turns red, and in the basic solution it turns yellow orange. Similarly, is thymol blue turns red when it is put in the acidic solution, and it turns blue when it is put in the basic solution. Brom thymol blue turns yellow when it is put in the acidic solution and turns light blue when it is put in the basic solution. Phenol red turns yellow in the acidic solution and it turns pink in the basic solution. So you may see here that there are certain pH ranges in which they changes the color. The color transition is taking place between the limited range of pH. So these by comparing the color of solution with these colors, we can determine what is the pH of that solution at a certain interval. So this is how acid-base indicators may be employed to determine the pH of that solution.